Well, hello. Welcome to our series tonight on arithmetic sequences. So, arithmetic might sound like a familiar word, arithmetic. And as you know, arithmetic means to add, and that's what arithmetic means. So, our goal tonight is to talk about adding. So, a sequence is arithmetic if the terms have what we call a common difference. Now, difference meaning you can add or subtract. And we denote this difference with the letter lowercase d. So you'll see the d throughout the formula here. So letter A, determine the next three terms in the sequence. So see what you think. I went from 3 to -2, -2 to -7. And remember, our goal tonight is arithmetic or arithmetic. So how do I get from 3 to -2? Well, clearly you added a negative number or subtracted. So I would say I subtracted 5. And if it's a common difference, common being the key word, I have to make sure I'm doing the same thing throughout. So to go from -2 to -7, I also had to subtract 5. So I would make a conjecture that identify the common difference, my d is equal to -5. I'm adding a negative number. So part A did say find the next three terms. So again, I'm just going to add a -5, or really subtract 5. And -7 minus 5 is -12. -12 minus 5 is -17. And -17 minus 5 is -22. B, given the first term and the common difference, find the next four terms. So here's the key to me, common difference. That tells me, let's make a note here, that it's arithmetic. Okay, which means I'm adding or subtracting depending if my common difference is positive or negative. So A sub 1 represents the first term, so I know my sequence starts with the number 1, and I need the next four terms. Well, the difference between all of them is a half. So if I go from 1 to the next number and the difference is a half, I think you can make the conjecture that the next number should be 1.5. The difference from 1 to 1.5 is a half. 1.5, the next difference has to be the same because it's common. They all have to be the same. 1.5 is going to go to 2, 2 to 2.5, and 2.5 to 3, and 1, 2, 3, 4. That gets us the next four terms. Number 2, give it a whirl on your own. Pause it. We've got the first term and the common difference. Come up with the next four terms. Pause it and then come back and check. So I'm hoping you're feeling pretty confident. I'm going to move my page over here. So I'm saying my first term is -2, and my goal was just to keep subtracting 3. Why subtract and not add? Well, technically I'm adding, but I'm adding a -3. So I'm going to go from -2 to -5, -8, -11, and I need one more to get the next four terms, so -14. So yesterday we introduced the words explicit versus recursive, and there is a formula you need to know for an explicit arithmetic sequence. Okay, and that is a sub n equals a sub 1 plus n minus 1 times d. Okay, so you might be thinking, oh dear, not another formula. Well, here's the good news. We have this lovely formula sheet that's pretty much useless for our exam, but they do give you this formula. So why don't you make a note? This formula is given, so we will be generous and give it to you on tests. However, they think that you should know recursive, and they do not give you this formula. So you do have to memorize the recursive, which is a sub n equals the previous term, a sub n minus 1. Arithmetic means add, so plus the difference. And don't forget, recursive means you have to be given the first term, or a term. So those kind of get grouped together. Okay, so again, they're going to give you this explicit formula. You're going to use it so many times that you probably won't need it, but they're giving you that, not the recursive. So I just like to have these fresh on my page. The explicit formula, which is given, and then the recursive formula, which is not. So question 1 says, if a sub 10 equals 8, and the difference is 3, find the next, or the first 5 terms. So here's where this formula is useful. Notice it didn't say anything about a previous term or a given, so I'm not going to use recursive right now. I know a sub 10 equals 8, so I'm going to replace all my n's with the number 10. So a sub 10 equals a sub 1, which I don't know, plus there's an n, so 10 minus 1, times the difference, which I know is 3. Now a sub 10, I already know that answer is 8, so I get 8 equals a sub 1 plus 10 minus 1 is 9 times 3. So I get 8 plus equals a sub 1 plus 27. So I get a sub 1 is equal to negative 19. So I'm using this formula to get a sub 1. Now that I know a sub 1, I need to list out the first 5 terms. Well, the first term is negative 19, and they all have a difference of positive 3. So if negative 19 and the next number is plus 3, I know I'm going to get negative 16. Then plus 3 is negative 13, negative 10, and negative 7. So you'll notice I'm using this explicit formula because I'm given this information to come up with a sub 1. All right, example 2. If a sub 1 equals 12 and a sub 5 equals 20, find the difference. So again, I'm assuming these are arithmetic. That was our goal today. So I'm going to start with my explicit formula. Notice it says nothing about a previous term, so I'm not worrying about recursive at the moment. So a sub n equals a sub 1 plus n minus 1 times the difference. Okay, so notice they were nice enough and they gave you a sub 1. So I can replace that with a 12 right off the bat. So I'm going to use the fact that I know a sub 5. So I am going to replace all my little n's with a 5. Plus 5 minus 1 times the difference, which I don't know. That's the question, of course. And now I can replace a sub 5 with the answer of 20. So 20 equals 12 plus 5 minus 1 is 4, d. Solve for d, subtract over the 12. 8 equals 4d, so I should get a difference of 2. And notice that's all the question wanted. What is the common difference? And it's a difference of 2. Okay, now it gets a little more exciting. Now they're going to give you the third term in the sequence and the 11th term. And we don't know what the difference is, and we don't know what the first term is, so that's our goal, is to find both of them. So again, I'm assuming it's arithmetic. I mean, I really should state that in the question, however, that's our topic tonight. So I'm going to use the formula a sub n equals a sub 1 plus n minus 1 times d. Okay, so I'm just going to take the first thing I know. I'm going to replace all my little n's with a 3. So a sub 3 equals a sub 1 plus, I'm going to do a little mental math, 3 minus 1 is 2 times d. And I know a sub 3 is actually 8. So I get 8 equals a sub 1 plus 2d. Okay. So I have to solve for a d and a sub 1. So what I want you to first do is box that in, and we'll see where we go. So now we'll attack the second piece of information. So again, I'm going to use my explicit formula, a sub n equals a sub 1 plus n minus 1 times d. And I'm going to replace all my little n's with 11. So a sub 11 equals a sub 1 plus, again, I'm going to do some mental math, 11 minus 1 is 10d. And I'll go one step further. I know a sub 11 is 12, so 12 equals a sub 1 plus 10d. And let's box that in. What you'll notice that we get is a system of equations. And we've done 2 by 2 and 3 by 3 this year with some pretty good success. So what I want you to do is we're going to take these two and we're going to put them together and we're going to solve this equation. So I'm going to take this first equation over here and I'm actually going to solve it for a sub 1. So I'm going to say 8 minus 2d equals a sub 1. Would you agree with that? I just subtracted this 2d over to get a sub 1. Now I can take this equation and I can substitute it into a sub 1 in the other equation. So I'm going to say 12 equals, I'm going to replace this a sub 1 with what it's equivalent to, 8 minus 2d, and then I have plus 10d. And I'm just simply going to solve this. So I have 12 equals 8, negative 2d plus 10d is 8d. Subtract my 8 over, I've got 4 equals 8d. Therefore, my difference is 4 over 8, which is equivalent to 1/2. So let's just take a quick refresher. The question said find d, which I just did, and a sub 1. So remember, I know 1, 2, 3. I know a sub 3, which represents the third term, is 8. 4, 5, 6, 7, 8, 9, 10, 11. And I know a sub 11 is 12. And watch, let me just verify. The difference is supposed to be a half, so this should be 8.5, 9, 9.5, 10, 10.5, 11, 11.5, 12. Nailed it. So it wanted a sub 1, so I really just want to subtract a half. So this should be 7.5 and 7. So to answer the final question here, a sub 1 should equal 7. All right, this time they want us to write a recursive formula. So remember, this is the formula that's not given. So in recursive, you have to be given the first term or a previous term. So I'm going to say a sub 1 equals a number. I have to be given a previous term. And then I say, okay, recursive means start with the previous term, a sub n minus 1. If it's arithmetic, I'm going to say plus the common difference. And I just have to have both those written down. So this first example is extremely generous. A sub 1 equals 12, and the difference is negative 7. Write a recursive formula. So look how simple this is. I have to know the first term. A sub 1 equals 12. There's my first part. Check. And now my formula is a sub n equals the previous term, a sub n minus 1, plus the difference. And they just told me the difference is negative 7. So there it is. There is the recursive formula with the first term of 12 and a difference of negative 7. Let's get a little more exciting. So our next example says, if a sub 15 equals negative 10, and the difference is 2, write a recursive formula. All right, so again, I'm going to jot my rule down for myself. I need to know a sub 1, and then the definition of recursive is the previous term, a sub n minus 1, arithmetic means plus the difference. So I just keep jotting those down, so I keep saying them to myself. So I know the difference, but I don't know a sub 1. So my goal is to go get that a sub 1. So I'm going to start with my explicit. A sub n equals a sub 1 plus the n minus 1 times d. Okay, now I know a sub 15 equals negative 10, so I'm going to replace all those little n's with a 15. So my n is 15, 15 minus 1 is 14, and I actually know the difference. They told me it was 2, so I'm going to say times 2. I'm just going to clean it up. I know a sub 15 is actually negative 10 equals a sub 1 plus 28. Subtract that 28 over, and I'm going to get a sub 1 equals negative 38. Now I think I'm ready to write the formula. I had to identify a sub 1, so a sub 1 equals negative 38. And then I need to use my recursive definition. A sub n equals previous term, a sub n minus 1, plus the difference of 2. And there is our recursive formula. So just take a minute to remind yourself that those are the two things that we're looking for, our difference and our a sub 1. Okay, this next example, again, is slightly different, and probably as tough as it's going to get there. If a sub 22 equals 143 and a sub 13 equals 80, let's write a recursive formula. So again, I'm saying to myself, I need a sub 1, and then I need to say the formula is the previous term, a sub n minus 1, plus the difference. So again, I don't have a sub 1, and I don't have the difference, so I have to find everything, basically. So I'm going to start with my explicit formula. A sub n equals a sub 1 plus the n minus 1 times d. I'm going to plug in my first term. So a sub 22, so I'm replacing all my little n's with 22, equals a sub 1 plus, can we do that mental math? 22 minus 1 should be 21d. And basically, I can't go I can go one step further. I know a sub 22 is 143. equals a sub 1 plus 21d. And now I can't go any further, so let's box that in. That is as far as I can go on that term. Now let's take the other term. A sub 13 equals a sub 1 plus n minus 1. So 13 minus 1 is 12 times d. And I know a sub 13 is 80. So 80 equals a sub 1 plus 12d. And again, that's as far as I can go on that one. So now we're back to a system where we're going to solve one equation and substitute it into the other. And it doesn't matter which one you solve for a sub 1 or d. To me, I think it's obvious to solve for a sub 1. If I wanted to solve for d, I'd have to divide something out of both of them, where a sub 1, I'm just going to subtract a term over. So I think to make life easier, solve for a sub 1. And again, it doesn't matter if you pick this equation or this equation. I'm just going to pick the first, but it truly doesn't matter. So a sub 1 equals, if I get this by itself, 143 minus 21d. Right? I'm just taking this 21d and subtracting it over. So now I'm going to substitute this into the a sub 1 in this equation. So 80 equals 143 minus 21d, substituted it in, plus 12d. And I'll just keep cleaning it up. 80 equals 143 minus 9d. I'm going to subtract that 143 over, so 80 minus 143 is negative 63 equals negative 9d. Divide out my negative 9 and I get a difference of 7. Now again, we're not done until we think about what we need. To be recursive, I need the first term and the previous term plus the difference. So right now I have the difference. I still have to figure out the first term. Well, look how simple this is. You have two equations. Both say a sub 1 equals. So I have this equation, or I could use this equation here. Since this one already says a sub 1 equals, I'm going to use this one. A sub 1 equals 143 minus 21 times the difference. And I just found the difference to be 7. So I've got a sub 1 equals 143 minus 147. So I would say a sub 1 equals negative 4. Now again, you should have got the exact same thing if you chose to plug it into this term and solve for a sub 1. It really didn't matter which one you plugged it into. So now that I have all my pieces of information, I can go and write my recursive statement. I need to state the first term, and then the recursive formula is a sub n equals the previous term, a sub n minus 1, plus the difference, so plus 7. And there you have it. There's our formula for our recursive sequence. Now our last example is going to involve some variables. So it says the first three terms of an arithmetic sequence are 2x, 5x minus 1, and 6x plus 2. And our goal is to find x and what is the numerical value of the fourth term. Okay, so here's what my head's saying. I know I have to add something to get to this one, and I have to add or subtract, I guess, the same thing to get to this one. So I'm basically going to write an equation to solve this. So what I'm saying is if I take this term and I subtract the previous term, so let me write that down. If I take my 6x plus 2 and I subtract its previous term, 5x minus 1, I should get the same answer if I take 5x minus 1 and subtract its previous term. So let me just make sure you buy that. I'm going to take this term and subtract this term, and whatever that difference is should be the same thing from this term minus this term, right? They should be the exact same thing. So now, why is this so important that I use parentheses? Because I have to take this negative and, distribute it through. So I'm going to say this is 6x plus 2, and this becomes minus 5x plus 1 when I distribute. This becomes 5x minus 1, and I just have that term to distribute it to, so minus 2x. So let's see, 6x minus 5x is x, 2 plus 1 is 3. 5x minus 2x is 3x, and then minus 1. And remember, my goal is to solve for x. So I'm going to subtract x. So I've got 3 equals 2x minus 1. Add that 1 over. 4 equals 2x. Therefore, x equals 2. Okay, so now let's see if we're correct. We solved for x, and now let's see if we can evaluate these terms. If x equals 2, what is our first term? Well, our first term would be 4. If x is 2, our second term would be 9. And if x is 2, our next term should be 14. Do we have a common difference? How do I get from 4 to 9? Well, I add 5. How do I get from 9 to 14? Well, I add 5. Looks like my common difference is holding. So what should the fourth term be? Well, if I add 5, I should get 19. Okay, so the whole key to solving for this, I couldn't really just guess random numbers. I had to say this term minus this term is the same as this term minus this term. Well, of course, just like always, we're going to get some great practice tomorrow, and we look forward to seeing you. Have a great night.